Hello, in this video we will discuss using the normal distribution to approximate binomial probabilities. A study conducted by the Pew Research Organization found that Facebook users get more than they give. Some of the interesting findings of this study were that 40% of Facebook users made a friend request, but 63% received at least one request. Users pressed the like button fewer times than their contact was liked, etc. So we see a pattern here. This pattern can be explained by the existence of power users, and this study found that approximately 25% of Facebook users are considered power users. The same study also found that the average Facebook user has 245 friends. Say we want to calculate the probability that the average Facebook user with 245 friends has 70 or more friends who would be considered powered users. Our givens are that the sample size is 245, the probability of success is 0.25, and we want to find the probability of getting at least 70 successes, or in other words, power users. We can find this probability using the binomial distribution, as the probability of exactly 70 power users, or 71, or 72, or all the way up to 245 power users, which is basically the union of all of these disjoint probabilities. But this seems like an awful lot of work to calculate each individual binomial probability. Let's try to visualize what we're aiming to get here. Here is a binomial distribution with n equals to 45 and probability success 0.25. We're interested in the probability of at least 70 successes, which is basically this shaded area. It should be clear that this looks a lot like a continuous unimodal and symmetric distribution you've seen before, namely the normal distribution. And this is not a coincidence. When the sample size is large enough, the binomial distribution with parameters n and p can be approximated by the normal model, where the parameters of the distribution, so the mean and the standard deviation, can be calculated the same way we would calculate the binomial mean and standard deviation, as n times p and square root of n times p times 1 minus p. So how do we know if the sample size is large enough? We need at least 10 expected successes and failures for the binomial distribution to look nearly normal. So let's check. N times p is 61.25 and n times 1 minus p is 183.75, which are both greater than 10, so we're good to go. As we can see, the normal and the binomial distribution indeed look alike. The mean of the distribution is 61.25, that's the expected number of power users among a sample of 245 friends, and the standard deviation is 6.78. Given a particular observation, a known mean and a known standard deviation, we can easily calculate the shaded area using a z-score. The score is simply the observation minus the mean divided by the standard deviation, which is 70 minus 61.75 divided by 6.78, 1.29. Using a normal probability table, we can look up the probability, or the area under the curve up to this point, and the complement is the shaded area we're interested in. Therefore, there's a 9.85% chance that more than 70 out of 245 Facebook users are power users. I hope that this video has been helpful for understanding how to use the normal model to approximate binomial probabilities. Thank you for watching.